Okay, up to now, we've been writing all of our code in the main function. We have called some library functions, but we haven't really written our own functions other than main. So that's the first half of what we're going to do here in Lecture 5. Then, in the second half, we're going to take a look at declaring and using arrays and another form of loop called the for loop that is convenient for stepping through, for example, all of the elements of an array by using subscripts. So, we already talked about the idea that a function definition has two parts. The first part is the declaration, which specifies how to interact with the function, and the second part is the body, which specifies what the function does. The declaration gives the name of the function, followed by a list of parameters contained in parentheses. Even if the function does not expect to receive any arguments, it's still necessary to have that parameter list. And then in front of the function name, we also have the return type. The body of code is contained between curly braces. So here on slide 3, we have two functions being defined. This code continues on to slide 4, and at the bottom of all of this code is where our main function is located. The function sayHi expects to receive no arguments, so its parameter list is empty. When sayHi is called, all that it does is display a line containing hi and a new line to the cout standard output stream object. And sayHi does not return any value, so we've declared void as its return type. This is one of the most common uses of the word void, is if you have a function that does not explicitly return a value like an int or a float or a char or what have you, then you specify that the return type of that function is void. In this next example, we have a function named sayStir that does expect to receive one string argument, and internally within the block of this function, within the body of the function, we can access this string using the parameter s. So sayStir needs to be passed an argument value, and it will display to cout that argument string followed by a new line character. On the next page, we have a third function being defined called lesser of. Now this function expects to receive two arguments that it will store in these parameter variables x and y. X is a double, y is also a double. And notice that when this function is done, it also will return a double as its result. Specifically, it will return the lesser of the values of these two arguments, x and y. The body is very simple. If x is less than y, we're going to return x. Otherwise, we're going to return y. It's perfectly fine in C++, by the way, for a function to have multiple return statements. All right, so here's a main function that is going to invoke these three functions that we have defined above main. sayHi simply calls hi, which displays a line containing hi with a new line character. sayStir displays by, the string literal by, the C string by, becomes the initial value for the parameter variable s, and we're going to display the value of s on a new line. And then in the third statement in main, which is long and split across these two lines, we're going to first display some text, the lesser of 7.7 fifths and 5.0 thirds is, okay, and then we're calling lesser of, which is going to pass in the results of these two divisions. All right, 7.7 fifths and 5.0 thirds. Those values are computed first, and their results become the values of the parameters x and y within lesser of. This function will return the result back to the point where the function was called. So that result value, that return value from lesser of, becomes a value that we are then going to insert or put to cout. Here's the output of the program. Okay, so the first statement, say hi, just displays hi on a new line. The second statement, say stir of by, displays by on a new line. And the third statement ends up displaying that the lesser of 7.7 fifths and 5.0 thirds is 1.54, which is, by the way, 7.7 fifths. So that's a little bit less than 5 thirds, which would be 1.666, etc. Okay. Now, we arranged the functions the way we did intentionally. You cannot call a function in C++ unless the compiler understands what the interface to that function is. In Python, we can get away with writing code that calls a function and then later on defining the behavior of that function, and that will work fine in a Python program depending on the order in which things get called. But the C++ compiler is very particular about analyzing each statement of code as it comes to it. And the compiler analyzes code token by token by token. It doesn't look at the entire file all at once and then try to figure things out based on the entire file. So we have intentionally defined our three functions, say hi, say stir, and lesser of, above main. Now, if we don't want to do that, we can put what's called a declaration of a function above where the function is called. And that will enable us to call the function even if the entire definition of the function, including the body, has not been seen yet. Now, a declaration just consists of the interface information. That is, a declaration consists of the return type, the function call, and the number and types of parameters that the function takes. And that's all we need. We can, if we wish, specify names for the parameters, but that's optional. It turns out that if we specify parameter names in a declaration, they're really just treated as documentation. So for example, a declaration of the lesser of function, remember that lesser of takes two doubles as arguments and returns a double as its result. That is, it returns the lesser of those two arguments. Each of these three statements here is a valid declaration of that lesser of function. Notice that it just consists of the name of the function, the list of parameters, including the types, but not necessarily including the names, and the return type, and then we have a semicolon stuck on the end. So that's all we need. We're allowed to put in parameter names like x and y, and that's fine. In fact, the parameter names that we use in a declaration don't have to have anything to do with the actual parameter names in the definition of the code. So we could, if we wanted, do something silly like saying the first parameter is cow and the second parameter is eggplant. All right. The compiler really just doesn't care about the parameter names that you give in a declaration. In fact, you can have multiple declarations of a function, but you're only allowed to have most one definition of a function, which includes the actual parameter names and the body of code in curly braces. Okay, so let's take a look at how we can use this declaration in our program. Here we have a revised program. This main function is not calling say hi or say stir. It's only calling lesser of. Let me highlight just lesser of. So here is lesser of being called. But because of this declaration above main, the compiler has all the information it needs to understand how lesser of is intended to be interfaced with, how lesser of is intended to be called, and what lesser of will return. Down below main, therefore, I can put the body of the full definition of lesser of, including its body of code in curly braces, and the compiler is happy. Now, the critical thing here actually is in a large working program, this lesser of function that we're calling may be defined in a completely separate file. Okay, so lesser of's definition may be in some completely separate file. It may, for that matter, be in some completely separate precompiled library of code that perhaps we downloaded from the web or bought from some third-party company. So we may not even have access to the source code, the implementation details of the lesser of function. All right, but we do need to declare lesser of before we can call lesser of, and then we just have to be sure that the actual implementation of the lesser of function matches up with the declaration that we've used. Okay, so the output when we run this program is simply going to be the lesser of 7.7 over 5, and 5.0 over 3 is, like we had before, 1.54, which is 7.7 over 5.